Hey guys, welcome to another episode of Learn with Sir Glenn, and for this video, I'm going to teach you how to sketch the graph of polynomial function. So, let's go! Before we proceed with graphing the polynomial function, let's have a review first of finding the zeros of polynomial function. Let's find the zeros of f of x equals x cubed minus 2x squared minus x plus 2. So here are the steps in finding the zeros. First, write it in standard form and equate it to 0. So we will have x cubed minus 2x squared minus x plus 2 equals 0. Determine the degree to find the maximum number of zeros that we're going to look for. So the degree is 3, so we're going to look for 3 maximum zeros. List the possible zeros. So we will have positive negative 1, positive negative 2. Then we're going to use the synthetic division to find the zeros by a trial and error. So we will have 1, negative 2, negative 1, 2. Then our aim is to have the last digit on the third row equal 0. So we're going to pick a number from our possible zeros. So let's have negative 1. So applying the synthetic division, you bring down 1, multiply, that's negative 1. Add, you will have negative 3, multiply, that's positive 3. Add, you will have positive 2, then multiply, you will have negative 2, then that will give you 0. So therefore, negative 1 is one of the zeros that we're looking for. Since we're going to look for 2 more zeros, we can just simply write this one in quadratic equation, x squared minus 3x plus 2 equals 0. Then we will use factoring, so that will give us x minus 1 times x minus 2 equals 0. Then we use zero product rule, so we will have x minus 1 equals 0, then x equals 1, then another one is x minus 2 equals 0, then x equals 2. So the zeros are negative 1, 1, and 2. So let's have another one. So find the zero of f of x equals x minus 2 times x plus 1 squared times x minus 1 cubed. So since the given polynomial is in the factor form, so we're just going to proceed with writing in standard form and equate it to 0. Or since it is in the factor form, we're just going to equate it to 0. Then after this, we're going to proceed with step 5, which is the zero product rule. So we equate each factor to 0. X minus 2 is equal to 0. So x equals 2. Then the other one is x plus 1 equals 0. So x equals negative 1. Then the last factor is x minus 1. So equate it to 0. Then we will have x equals 1. So since we have your exponents, then we will have repeated 0. So there will be 2 negative 1 because of the exponent 2. There will be 3 positive 1 because of the exponent 3. So when you write the zeros, you will have negative 1 multiplicity of 2, 1 multiplicity of 3, then 2. Let's proceed with sketching the graph of your polynomial function. So here are the steps in sketching the graph of polynomial function. So step 1 is to find the zeros, then write the function in factor form. Step 2 is to determine the end behavior of the graph of the given polynomial function. Then step 3 is to list the zeros and multiplicity to determine whether to cross or touch the x-axis at point C. If you have even multiplicity, the graph touches x-axis at point C, just like this one. And if you have odd multiplicity, the graph crosses x-axis at point C, just like this one. Step 4 is to make a table of values for x and y. Then the last one is step 5, which is plot the points and draw a smooth continuous curve to connect the points. Okay, so now let's sketch the graph of f of x equals x cubed minus 2x squared minus x plus 2 using the steps in sketching the graph of polynomial function. Since we already have the zeros of this, so we will have zeros are negative 1, 1, and 2. We're going to proceed with the factor form. So writing this one in the factor form, we will have f of x equals x plus 1 times x minus 1 times x minus 2. So we do this so that it will be easier for us to solve for the table of values later. Then after this, we're going to determine the end behavior. So since the degree is 3, which is odd number, and the leading coefficient is positive, the end behavior will be falls to the left and rises to the right. So meaning when we start sketching our graph, the left side of our graph is falling and the right side of our graph is rising. Then step 3 is to find the zeros and the multiplicity. So we have negative 1, 1, and 2. Since the multiplicity of these zeros are all equal to 1, then we will have the graph will cross all these points at x-axis. Step first to make a table of values. So we will have table of values for x and y. So we're going to assign the values of x, but make sure that you have all the zeros on your values of x. Then after that, we're going to solve for the values of y using the if and then relationship of x and y. So since negative 1, 1, and 2 are all zeros of your polynomial function, automatic that the value of y for those values of x are all 0. If x is equal to negative 1, we will have y equals 0. If x equals 1, we will have y is equal to 0. And if x equals 2, you will have y equals 0. And all you have to do is to solve for the remaining values of y given the values of x. So for that, we will have if x equals blank, then y equals blank. Then using the factor form, we're going to solve for y given the values of x. So if x equals negative 2, to solve for y, we're going to replace the x with negative 2. Thus, we're going to have y is equal to negative 2 plus 1 times negative 2 minus 1 times negative 2 minus 2. Solving for this, we will have negative 1 times negative 3 times negative 4, and y is equal to negative 12. So meaning if x equals negative 2, then y is equal to negative 12. So we're just going to put it on our table of values. Okay, next, if x is equal to 0. If x is equal to 0, solving for y, we're going to replace the x with 0. So after this, we will have 1 times negative 1 times negative 2, which will give us positive 2. So if x is equal to 0, then y is equal to positive 2. Then we have if x is equal to positive 3. So if x is equal to positive 3, we will replace x with 3. So we will have y is equal to 3 plus 1 times 3 minus 1 times 3 minus 2. Y is equal to 4 times 2 times 1. That will give us 8. If x is equal to 3, then y is equal to 8. So since we already have table of values, so what we're going to do is to make set of ordered pairs from our table of values. Okay, so we will have negative 2, negative 12, negative 1, 0, 0, 2, 1, 0, 2, 0, and 3, 8. Then all you have to do now is to plot the points. So since we're going to plot the points, we're going to use the Cartesian plane. Then we're just going to plot each point on our Cartesian plane. So first, we will have negative 2, negative 12, then negative 1, 0, 0, 2, 1, 0, 2, 0, and 3, 8. Then all you have to do is to connect these points using a smooth continuous curve. But make sure that you have to follow the end behavior. So meaning on the left side, we will have the graph falling. On the right side, we will have the graph rising. Then we also have to follow the multiplicity. We also need to follow if the graph will cross the zeros or if the graph will touch the zeros. So for this one, we're going to cross the zeros. So the graph will be something like this. So notice that on point negative 1, 0, we cross the point. The graph crosses the point. And so with points 1, 0, and 2, 0. Then on our graph, we will have turning points. Point on the graph where your graph changes the direction from rising to falling or falling to rising. The number of turning points can be obtained by getting the degree, then minus 1. So the maximum number of turning points for the graph of the polynomial function is degree minus 1. Okay, so let's have another example. So sketch the graph of f of x equals x minus 2 times x plus 1 squared times x minus 1 cubed. So the zeros are negative 1 multiplicity of 2, 1 multiplicity of 3, and 2. So in sketching the graph, we have to write it in the factor form. So since it is already in the factor form, we're just going to copy it. Then we have to determine the end behavior. So to get the end behavior, we multiply all the leading coefficients of our factors, and that will give us x raised to 6. So since the degree is an even number and the leading coefficient is positive, then we will have the end behavior as rises to the left and rises to the right. So meaning on the left side of our graph, we are rising. On the right side of our graph, we're also rising. Then the zeros and the multiplicity. So we will have first negative 1 multiplicity of 2 So since 2 is an even number, so we will have touches. So meaning the graph will touch the x-axis at point -1. Then we have 1 multiplicity of 3, which is an odd number. So therefore, we're going to have the graph crosses the x-axis at point 1. Then we have 2 multiplicity of 1, so that's odd also. So we will have the graph crosses the x-axis at point 2. Then we're going to make a table of values. So table of values for x and y. So we were going to assign the values of x, but make sure that you have all the values of your zeros on those values of x. Then for the y, we're going to solve for the values of y using the values of x. First, we will have if x is equal to -2, then y is equal to 108 using the if and then relationship between x and y. If x is equal to -1, that will give you y is equal to 0. If x is equal to 0, you will have y is equal to 2. If x equals 1, you will have y is equal to 0. If x equals 2, you will have y is equal to 0. Then if x equals 3, you will have y is equal to 128. Then from here, we're going to make an ordered pairs. So we will have -2, 108, -1, 0, 0, 2, 1, 0, 2, 0, and 3, 128. All we have to do now is to plot the points, then connect the points to smooth continuous curve. So first we have -2, 128. So since that is -2, 128, we cannot put it on this Cartesian plane since we only have small space. So we're just going to assume that it is somewhere here. Then we have -1, 0. So that's -1, 0. Then we have 0, 2. That's 0, 2. Then 1, 0, 2, 0, then 3, 128. So since that is 3, 128, and we cannot put the 3, 128 on our Cartesian plane here, you're just going to assume that somewhere at the top of your Cartesian plane. So all you have to do is to connect these points using a smooth continuous curve, following the end behavior and the touches and crosses thing. So we will have this graph. So notice that the graph touches -1 on x-axis because it has a multiplicity of 2, which is an even number. Then we have crosses at 1 because it has multiplicity of 3, which is odd number, and so with point 2 because it has multiplicity of 1. Then the left side is rising, the right side is also rising. So that's it. Thank you for watching and hope you have learned something from this video.